Lesson 3-4, you'll be classifying and comparing numbers in the real number system. The real number system is made up of rational numbers, which we talked about earlier in Chapter 2. Those include numbers such as whole numbers, 0, 1, 2, 3, 4, and so on. Integers, which are all the whole numbers and their opposites, like -1, -2, -3. And then rational numbers, remember, were numbers that could be written as a fraction. Irrational numbers are numbers that cannot be expressed as the quotient a over b, where a and b are integers and b is not equal to 0. Basically, if you have a number that cannot be written as a fraction, it's an irrational number. Some common examples of irrational numbers are square roots of some numbers. Not all, but many, such as the square root of 2, which is about 1.4142. It keeps going on and on without repeating. If it goes on and on without repeating, it cannot be written as a fraction. Same with the square root of, or the negative square root of 3. Another very common or famous irrational number is pi. Pi is 3.14159 and even more if I had time. It keeps going on and on and on forever without repeating. Therefore, it is irrational. I sometimes like to call irrational numbers the crazy numbers. Just like if somebody is being irrational, they're not thinking clearly, they're maybe being crazy. Those crazy numbers that go on forever, irrational, as long as they aren't repeating. In the first example, 0.252525, the decimal has a repeating pattern, therefore it's a rational number. We can write this number, since it's repeating, we can write it as a fraction. If you remember back in Chapter 2, if you have 2 digits repeating, it's over 99. So 25/99, since I can write it as a over b, where a and b are integers and b is not equal to 0, we can go ahead and say that is a rational number. Now we're supposed to say all the sets that it belongs to. This one only belongs to the rational numbers because it's not a whole number or an integer. Square root of 36. Once you simplify the square root of 36, you get 6. And 6 is a whole number. And whole numbers are also integers, which are also rational numbers. So it's going to be all three of those groups. It's going to be a whole number, an integer, and a rational number. Number 3, the negative square root of 7. Well, square root of 7, if you were to type that into a calculator, it's about 2.645751311, and you're not going to see any pattern, and it doesn't terminate, so therefore it's an irrational number. If it's an irrational number, it isn't anything else other than a real number, and these are all real numbers that we're talking about here in middle school, so we don't need to say it's a real number. Eventually, when you get to high school, you may learn about imaginary numbers. You may want to pause the video and try the next couple on your own. If you need to use a calculator to check the square roots, you can do that. The first example, square root of 10. Square root of 10, if you were to type that into your calculator, you would get a decimal number that is not terminating, meaning it doesn't end and it doesn't repeat. Therefore, that one is going to be irrational. -2 2/5. Obviously, that one can be written as a fraction, so it is going to be rational. But it isn't any of the special types of rational numbers, such as whole numbers or integers, so we just stop right there. Square root of 100 is 10, and 10 is rational because I can write it as a fraction. Not only is it a rational, it is also a whole number, which means it's also an integer. So this one right here is going to be rational. It's a whole number, and it's also an integer. Next up, we're going to be graphing real numbers. It says estimate square root of 6 and negative square root of 3 to the nearest tenth, then graph square root of 6 and negative square root of 3 on a number line. Well, you're going to want to just type these into your calculator. You're going to want to look for the button with the radical symbol. Some calculators you type it in first and then the number. Other calculators you type in the number and then the square root symbol. So you'll need to try it out on your calculator. And if you can't figure it out, you'll need to be sure to ask in class how to do it on your calculator. Square root of 6 is about 2.449489743, or about 2.4. So you're going to go on the number line. You're going to find positive 2 and positive 3, and it's going to be just a little under halfway between the 2 and the 3. So I'm going to put a dot there, or a point there, and I'm going to label that as the square root of 6. Negative square root of 3, well, the square root of 3 is about 1.73205, and so on. No repeating. It's another irrational number. It's negative square root of 3, though, so we're going to look at between negative 1 and negative 2 on the number line, and it's closer to negative 2, so we're going to put our point not quite on the negative 2, and we're going to label that negative square root of 3. You may want to pause the video and try the next 3 on your own. Square root of 5. Square root of 5 is going to be a number between, see, it's going to be between 2 and 3. I don't have my calculator handy, but square root of 5, 2 squared is 4 and 3 squared is 9. So it's going to be a little bit more than 2, but less than 3. It's closer to 2 than it is to 3, so I'm going to put it about right there. Again, you can use your calculator to check what exactly the square root of 5 is. Go ahead and label that. Negative square root of 7. Well, square root of 7 is going to be between, let's see, it's going to be less than 3. It's going to be less than 3, but more than 2. Because the square root of 4 is 2 and the square root of 9 is 3. And since it's negative, we're going to put a negative there. It's going to be actually closer to, it's closer to this one. So it's going to be closer to negative 3 than it is to negative 4. So it's going to be about here. And I'm going to label that negative square root of 7. Now 22 is between, let's see, perfect squares of 16 and 25. And so that means it's going to be between 4 and 5. It's going to be a little closer to 5. So I'm going to go on my number line between 4 and 5, but closer to 5. Again, you can use your calculator to find out exactly, or I should say to the nearest tenth, what it would be. But Square root of 22 is about right there. Now the next thing you're going to be doing is comparing real numbers. The first one is the square root of 7 and then 2 2/3. Well, the square root of 7 is about 2.64575 and so on. And 2/3 we know is 0.6 repeating. So if I'm comparing these two decimals, 0.6 repeating is going to be bigger than 0.64. So when you go to graph those, here's 2.6, here's 2.7. Its square root of 7 is going to be a little bit smaller than 2 2/3. So we're going to go ahead and put square root of 7 is less than 2 2/3. Now if we're comparing 1.5 repeating and the square root of 2.25, square root of 2.25, if you were to type that into your calculator, you would get 1.5. And when you compare 1.5 repeating and 1.5, 1.5 repeating is bigger because 1.555555555 is bigger than 1.50000. If you compare, the next number would be a 5 and here the next number would be a 0. So 1.5 is going to be smaller. This one right here is going to be smaller than 1.5 repeating. Now you may want to pause the video and see if you can do these ones on your own. Square root of 11 is less than 3 1/3. Square root of 17 is greater than 4.03. And square root of 6.25 equals 2.5. The last example says on a clear day, the number of miles a person can see to the horizon is about 1.23 or 1 23/100 times the square root of his or her distance from the ground in feet. Suppose Ricardo is at the top of Ion Center and Kia is at the top of the Sears Tower. How much further can Kia see than Ricardo? Well, it's 1.23 times the square root of his or her distance from the ground. So this person is 1.23 times the square root of 1,136. And the other person is 1.23 times the square root of 1,451. And you would just type those two problems into your calculator. And when you do that, you get these two numbers about. And so now if you want to know how much further Kia can see, you would want to take her distance she can see and subtract the other person from it. When you do that, you get about 5.39 or 5 39/100 miles.